So today you will be taking your elves, your humanoids, your mermaids, whatever, their chromosomes through meiosis. And step one of doing that, provided you have transferred all the alleles correctly to the chromosomes, is to cut those chromosomes apart. You are going to need your scissors. If you forgot your scissors today, I got a bucket of them up here. So you're going to take your elves, humanoids, mermaids, whatever's chromosomes, cut them apart. Don't be that kid that feels like they have to perfectly hug the lines of every chromosome. Does not matter. Like blocks is fine. Like cut here, and then start to cut them apart in like roughly rectangular shapes. That is perfectly adequate. We want a little bit of speed here. Get them apart, and we'll get rid of the excess paper, and then we'll move on. And if you just take that pile of chromosomes and kind of jumble it up on your desk, we are now officially in early prophase 1. So from early prophase 1, we move to late prophase 1, where of course we're going to have to pair the homologous chromosomes with each other. Not lined up in the middle yet. Just get them next to each other. But in such a way that you can see all the alleles of each pair. And we are going to now make crossing over happen in the best way that we can. Of course, there's only 14 genes. That's pretty simple, much simpler than any real living organism. So what we're going to do for crossing over looks like this. You're only going to do it where it matters. And of course, it only matters. Trading alleles here is only going to matter where your elf is or humanoid is heterozygous, right? So you're going to ignore anything where it's 4 big letters or 4 little letters, because switching those wouldn't matter at all. But every place that your humanoid is heterozygous, for example, if you have, whoa, crap. If this were your humanoid and there was 2 little R's on one chromosome and 2 big R's on the other one, you would pick one of those littles and one of those bigs, and you would change them to the other. It doesn't matter which 2, but you're going to take one of them and turn it into a big one, and then you'll take one on the other chromosome and turn it into a little one. That is a permanent change that you're making. Just if you're in pen, go ahead and put the X's and change them. If you got it, if you did pencil, you're welcome to erase them. But only in one spot, right? You're only doing this in 2 of the 4 alleles, switching them. Try to do it a little different in some of the places, but so every heterozygous trait you've got, you're doing that one time. Any questions about that? You're crossing over, right? That's what we call this. If we'd had a quiz today, you would have gotten that right, right? Here's a question I love. What 2 things in meiosis cause us all to look different from each other? What 2 events? And in what phases of meiosis do they happen? If you don't know the answer to that right now, you need to study more before tomorrow. What better way? Hey, what better way to ensure a snow day than to announce a quiz, right? Yeah.
Okay, now.
I'm here for you. You're at all confused. Ask, please. Do not cross the gender. Okay? Gender is actually 2 whole chromosomes. It's not one gene. It's a whole bunch of genes that are on those chromosomes. So it would never, the whole chromosome crossing over wouldn't happen. Yeah. So every place that your werewolf or whatever is heterozygous doing. Anybody else confused? So like I did it this way on this one. Maybe on this one, I decide, well, okay, I want to do the two left ones here. I want to do this one and this one over here. Do it different spots. Doesn't matter. We're trying to be as random as we can so that our gametes that we wind up with here end up different from each other, so that our offspring elves end up different from the parents and different from each other. Everybody good? So from there, it's on to phase one. Where they line up, but they line up in pairs. Does not matter top to bottom what the order is. Get them lined up in pairs, not single file, but in pairs next to each other, so that one is definitely on one side and one is definitely on the other side. And now to kind of poorly simulate independent assortment, you're going to pick two of those pairs. Your call, which two, don't care. You're going to pick two of those pairs and simply switch them. Like maybe I wanted to pick these two and switch what side they were on, and these two, switch what side they're on. And just like that, the hard part is over. Right, we've done the thing that makes the diversity in meiosis. And so from here, it's just split them apart, right? Not down the middle of the chromosome. Just move the pairs apart from each other. Yep, you got it. And now imagine the little butt thing forming, and imagine the nuclear envelopes coming back, two of them, right, around each of your piles. You can kind of jumble each separate pile a little bit, make it a little more end of meiosis one looking, and pause while I give you this, in which you are going to draw what you have at this point. We're just going to draw this two times, once at the end of meiosis one, once at the end of meiosis two. And so here and here, these two big sideways ovals, you're going to draw the chromosomes that you have. Now, once again, don't be that kid that has to draw the exact shape and color of each of these chromosomes. I just wanted to make them look pretty for you. You, when you draw them, are welcome to just do the stick figure thing, as long as you get those letters correctly. Pay close attention to what letters you have and get those right, and we're good. Here's that. We'll try not to move too much air when I set these down. You try not to sneeze. It's going to get a little bit delicate once we cut them apart. Okay, moving on into meiosis 2, prophase 2, which is the same as the end of meiosis 1, right? Except that nuclear envelope's gone away. Then let's move to metaphase 2, where they line up single file. Now be careful when you do this that they are vertically oriented, right? You're going to end up cutting these apart with your scissors. And you'd hate to cut it if it was sideways. You'd get different genes and your gametes be all messed up. Yep. Now here's where you got to kind of be careful, because you're going to be, as we move into anaphase 2, right, you're going to be snipping the chromosomes down the center at the centromere. And you're going to want to make sure and keep those columns of chromosomes, which are each going to wind up in a separate cell, right? Like, so this is going to end up being one cell, and this is going to be another cell. Don't mix them up, and don't cough or sneeze, because they'll go everywhere, right? Keep them Once you've cut them, keep them oriented the way they were and move them a little further apart to be safe. And so now we move from anaphase 2 over to telophase 2, where you kind of just separate those columns a little further, jumble each one up separately. Don't mix them, right? Keep the columns apart, but jumble them up so they look like what would be in the new nuclei that are forming. And we're almost done here. All you got to do now is draw, once again, like you did at the top of the page, draw what's in each new cell. You know, kind of jumbled around, but make sure you get those alleles, upper and lowercase, correct in each new cell. Good. Good job. Might be the easiest it's gone all day, so it did work. I do have a second guided reading for you. You notice that the first one was not a whole lot, and so this one is sort of part 2 of the chapter 11 guided reading. It's also not a whole lot, very easy. This will be due Wednesday, whether we have school tomorrow or not, or whatever the next day after Wednesday we have. Yeah.